Alright, so in this video, we are going to discuss the February-March 2026 paper 3-2. Let's have a look for question number 1. Okay, so we are required to solve this equation and then give our answer to 3 significant figures. Right, so when you're having all the indices like the number with the power, right? Usually what I prefer to do is that I have to separate all the power first and simplify the equation before I can continue to solve it, right? So for this particular example, there are a few important rules that we need to know where we are going to, we have learned before, right? A power m multiply with a power n, and we are getting a power m plus n. All right, then to solve this equation later, we are going to do it the other way around. That means we are going to do it backward. All right, so when we are having 2 power x plus 2, we are going to separate become 2 power x multiplied with 2 power 2. Simply happen for the minus, yeah? If I'm having a power m divided by a power n. So what am I having here for the power is a power m minus n. Same thing happen in this equation later, we are going to do it in the reverse way, where we are going to separate the power become 2 different numbers, okay? All right, so let's start with our equation here. I'm having 4 multiply with 2 power x plus 2, then minus 5 multiply with 2 power 2 minus x, then equals to 3. Okay, so first of all, I would like to apply this particular indices rule in this part. When I'm having 2 power x plus 2, I want to do it backward, become this number. Therefore, I'll be having 4 is a constant. I just copy, I don't touch anything. 2 power x plus 2. I can separate, become 2 power x multiply with 2 power 2. Okay, same thing happen for the second term here, 5. Just copy. 2 power 2 minus x. I want to separate according to this indices rule, where I want to separate them become 2 power 2 divided by 2 power negative 2. All right. Sorry, 2 power 2 divided by 2 power x. Sorry, huh? Okay, so I'm having 2 power 2 minus means divide, then 2 power x. So if you feel that it is quite weird for you to write out in this way, then you can just write it out like this. 2 power 2 divided by 2 power x. Then I bring the 3 over, equals minus 3, make it become negative 3, then equals to 0. Okay, all right. Then you can see that when we are having the 2 power x here as a denominator, right, it is a bit troublesome for us. And then from what I can observe from this part, right, I'm having 2 power x and also 2 power x, which is something in terms of x. So if you want to make your calculation easier, you can let y equals to 2 power x. And from here, simplify all this value here. 4 multiply with 2 square is a 4, so 4 times 4 is 16, so you're having 16y. Minus 5 multiply with the 4 on top, so you're having 20, so you're having 20 over y. Then minus 3 equals to 0. To get rid of the y as a denominator, I multiply the whole equation by using the y. So I'm having 16y squared minus 3y minus 20 equals to 0 eventually. And continue from here, you actually can see that we are getting a quadratic equation, right? So to solve a quadratic equation, you can try to factorize them. I think too bad this equation cannot be factorized. So what we are going to do is like we have to use quadratic formula to solve for the equation, to solve for the value of the y. So the value is negative b. So b is what? Negative 3. So all this you learned in the AS before, right? So plus minus b squared minus 4ac. So what's your b squared? Negative 3 squared minus 4a and also c. Divided by 2a. So divided by 2 multiply with 60. Okay, then basically you'll be having y equals to 3 plus minus square root 1289 divided by 32. Okay, so I try to solve it further. I'm having 2 answers for the y. So y is 2 power x, right? So I'm having 2 power x equals to 3 plus square root 1289 divided by 32. Another answer is 2 power x equals to 3 minus square root of 1289 divided by 32 as well. One is plus, one is minus, right? Okay, so we try to press for the calculator. If you press for the right hand side of this particular equation, you'll be getting a negative value. So when you have negative value here, later if you want to solve for the x, you have to take ln or log both sides. Log any negative number will give you a math error. Therefore, for this particular equation, we are going to ignore it. And we focus only on the first part, this one. Alright, so to get the value of x, basically you need to take ln both sides so that you can pull the x in front. Then ln, and take note, yeah, when you want to take ln, right, it must be the ln for this whole thing, this whole value here. Okay, then you need to press calculator a little bit to help you to get the simplified answer. Okay, so if you didn't do any careless mistake when you press calculator, by right you should be having a long value lah. Then please cut it short into 3 significant figure, it will become 0.282. Alright, so this is basically how we solve question. Right, so we are at question number 2. We are given the complex number z that satisfies modulus z equals to 9, and also the argument z is from pi over 2 until pi. So first of all, on first part A, they want us to draw the locus of points representing z. Okay, so first of all, let us have a look for the locus z first. For this locus z, basically we're having the modulus z equals to 9. That means if you want it to be more detailed, we are having z minus a complex number equals to 9. And this complex number here is 0 plus 0i lah. So which means when you're having any side with left hand side with complex number z minus a complex number equals to 9, this kind of locus is basically a circle with a center of 0, 0 and also with a radius of 9. Alright, so when you're having the center as a circle, the center of the circle is 0, 0 with the radius 9. So your z basically is this whole thing lah. Alright, you pass through all the important points at the 9. So these are the z. If let's say we are looking for this particular equation, right, the modulus z equals to 9. But they have another restriction here where the argument of z must be between pi over 2 until pi. So argument of z means that I'm going to get the argument of z minus something, a complex number, which is between pi and also negative and pi over 2. Alright, so what's the complex number here again? So it should be 0 plus 0i. That means the locus of the point z, the argument for point z from 0, 0 is from 90 degree to 180 degree. So just now I already draw a circle, right, in red color. Let's say now my z is here. Let's say this is the z on the locus. Then when I try to draw a line, z, okay, a straight line z to 0, 0, and I try to measure the angle, so this is the argument of the z. Alright, so very obvious, this argument of z is not between pi over 2 until pi, because pi over 2 must be 90 degree, then pi must be 180, right? So where should my z located? So according to this second restriction here, my z should be located here. So that when I draw a straight line from z, from the point z to the center 0, 0, I'm having the angle which is pi over 2. Alright, then if I draw my z here, slightly further from the first z that I draw, okay, if I draw a line from z to the center, from the 0, 0, I also get the angle that's more than pi over 2 but less than pi. So if you try all the points of z, right, you will realize that the final z that you should get is this one. It is because of when I try to draw this z and measure, connect it with the 0, 0, the angle that I have between 0, 0, between the positive x-axis to the z, it is actually a pi. Alright, so where is the line or where's the locus that fulfill these two conditions here? Right, so basically, the line that fulfill these two conditions will be all the z that lies on this second quadrant here. Okay, where you realize that on this line, all the z is having the distance from 0, 0 is 9 unit, and also the angle is between pi over 2 to the pi. All right, so the final answer for this particular locus will be something like this purple color curve that fulfill the both condition or condition given in the question. Okay, so this whole purple color part here is the locus of the z. So this is part A. Then they want us to have a look for part number B. On the same diagram, sketch the locus of the point representing z conjugate plus 3. Okay, so first of all, let's have a look for z conjugate first before we add the 3 there. Alright, so how can we draw a z conjugate? Let us take a very simple revision, yeah? A lot of students might not aware, but I don't know whether you are aware of these small details or not. Let's say I just take a simple example. Let's say I'm having z equals to 2 plus 2i. So what's the value for z conjugate? So the z conjugate will be 2 minus 2i, agree? When you are trying to sketch 2 plus 2i on your Argand diagram, it will be in the first quadrant. So let's say this is a z and this is 2 plus 2i. How are you going to sketch z minus 2i? Z conjugate, which is 2 minus 2i. So 2 minus 2i means that it will be in the opposite quadrant, in the fourth quadrant. So this will be your conjugate z. So that means if your z is in the first quadrant, then your z conjugate will be in the fourth quadrant. Alright, so let's take another example. How about if let's say I'm having my z equals to in the second quadrant. Let's say I'm having negative 2, positive 2i. Then my z conjugate now will be negative 2 minus 2i, right? So negative 2 plus 2i will be somewhere here. Let's say this is your z. Okay, negative 2 plus 2i. Then where's my negative 2 minus 2i? It will be in the quadrant below. Okay, so your z star or z conjugate will be in the fourth quadrant. In the third quadrant. If let's say your complex number is in the second quadrant. Alright, so from these two examples, right, you can try out more. Okay, you can try out more. Try a few more set of z and z conjugate and try to observe where you plot your diagram. You realize that when you want to plot the z and also the z conjugate, basically the z conjugate is the reflection through x-axis of the z. So that means it is an up-down reflection between the z and also the z conjugate. Alright, so you can try a few more examples so that you understand better. Alright, you can observe it better. Okay, so remember, z and z conjugate, right? The relationship is of each other is the reflection of each other through the x-axis. Okay, right. Then let's come back to this particular z here. In part A, my z is this purple color graph, right? How about if I want to sketch z conjugate according to what I have here? Therefore, the z conjugate will be the reflection through the x-axis for the z. So your z conjugate should be something like this. Okay, so this is your z conjugate. But now this is not my final answer because they are asking for z conjugate plus 3. Alright, so when you're having a plus 3, this plus 3 belongs to real part or imaginary part. There's no I here, right? There's no I here. Therefore, it is belongs to the real part. Which means that if your z conjugate is x minus yi, let's say, okay, then plus 3. Basically, you are having x plus 3, then minus yi. You will see that your y does not change at all, but you need to plus 3 unit to your real part. When you are going to plus 3 in your x-axis, that means you are going to move your whole locus 3 units to the right. So this one also, you have to move it 3 units to the right-hand side. Therefore, I'm trying to move this negative 9 here, become negative 6. And then this 0 here, I have to move it to the point of positive 3. So if I try to maybe label a bit, so my point will be somewhere here. Okay, then this particular curve, I will need to shift it 3 units to the right-hand side. So that means my diagram will look something like this. Okay, all right, and therefore, this is basically our z conjugate plus 3. for the blue color graph. Okay, all right. Therefore, you need to aware that to sketch the z conjugate plus 3, first of all, you need to understand what's the relationship between the z and also the z conjugate. That's the first point. All right. So you know that it is the reflection of each other through the x-axis. Then after you draw it, then you try to observe what do we have for z star or z conjugate plus 3. This plus 3 belongs to the real part, which is the x, and it also means that you have to move it 3 units to the right hand side. Okay, therefore you shift your whole graph 3 units to the right and your curve eventually will look something like this. Okay, so please make sure that you label it clearly, which is z conjugate plus 3. Alright, yeah, so this is how we solve question number. Alright, so we are now at question number 3. They want us to find the exact value of this integration. 3 sine x sine 2x, and then give our answer in this formula, p sub 3 plus q sub 2, where p and q are rational. So rational can be an integer, or maybe it can be it cannot be it can be an integer because integer belongs to rational number as well, right? So rational, in short, we are going to simplify as a fraction, like 1 over 2, 2 over 1, all these are rational number. Okay, so let's have a look for this integration first. All right, first of all, you need to understand, or you need to have an idea what is the correct technique to solve this kind of question for the integration. All right, so of course, you need to practice a lot so that you know how to identify the particular pattern by yourself. And I will give you a hint here. For this one, basically, you have to use compound angle formula. All right, because both of them are sine functions, sine x and also sine 2x. So in my opinion, I feel that it is easier for us to use a compound angle formula to solve it. All right. Okay. So what is the compound angle formula that involves sine and sine, sine A, sine B? You're having sine A and sine B, right? So for me, I will want you to use the compound angle formula for the cos. Because when you're having cos A plus B, or A minus B, then you will be having cos A cos B. Okay, then negative plus sine A sine B. So mainly I want to keep the sine A sine B, where I'm using a pair of the complex compound angle here in the trigo. All right, okay, so this is generally our direction. Okay, we have to use this compound angle formula to solve for the integration here, right, for this one. And the second thing is, when you want to form the compound angle formula, right, we always prefer to take the larger angle in front so that you won't get the negative angle inside your calculation for the compound angle. Okay, so we do a little bit of small changes here. So we are trying to move this one as A, which is a bigger number. Then this is a B. Okay, all right. So I will basically let like this, because I already told you I want to use compound angle for the cos, right? So first of all, I want to have cos 2x plus x first, where this is like your A and this is like your B. You're having cos A plus B. So what do you have for cos A plus B here? You should be having cos A cos B minus sine A sine B. Okay, then if I combine these two angles together, 2x plus x, I'm having cos 3x. And it is equals to cos 2x cos x minus sine 2x sine x. Alright, then after that I want to use the other pair where I want to use cos A minus B. So cos A minus B. That's the reason why I want to put a bigger number in front, right? Bigger angle in front is to avoid I'm having a negative angle here. It will be easier for us to during our integration process as well. All right. Okay, so I'm always putting the bigger angle in front. So I'm having A, then minus B. So what do I have here is cos A cos B again plus sine A sine B. Okay, simplify this angle here. I'll be having 2x minus x is an x. So cos x equals to cos 2x cos x plus sine 2x sine x. And I will make this as my second equation. Okay, all right. So if let's say I'm having a pair of compound angle here, right? What can I do so that I want to keep only sine 2x and sine x in my integration? All right, so that means I don't want the cos 2x cos x. I also don't want this one. I don't want the cos 2x cos x because we don't need this in our integration here, right? We want the sine 2x sine x. So to have this sine 2x sine x, what I need to do is I have to take my equation number 2 minus equation number 1. So I take this whole equation minus the first equation here. So from left hand side, cos x minus cos 3x, you're having cos x minus cos 3x. Equal sign, you put equal sign. Okay, then after that, cos 2x cos x minus cos 2x cos x becomes 0, right? Then for this one, sine 2x sine x minus negative sine 2x sine x. Therefore, you're having 2 sine 2x sine x. And hence, what do you see here? My sine 2x sine x basically can be written as half, then cos x minus cos 3x. Okay, all right. So I have successfully found out a suitable identity for the integration in my sine 2x sine x. Because if you change it, become this pattern, basically you can integrate it term by term. All right. Okay, so let us copy the question now. I'm having pi over 3, okay, then to pi over 4. So I want to integrate from pi over 3 on top to pi over 4 at the bottom. I'm having 3, then sine 2x sine x. Okay, so first of all, I take out all the constant here. 3 is a constant, I take it out. I want to replace sine 2x sine x by using this one, right? So I'm having the half also, which is a constant. I also take it out. And basically, I just having this. Okay, so I'm having only cos x, then minus cos 3x. All right. Okay, then I can start the integration because all these values I can integrate it directly. When I integrate cos x, what do I get? I'll be having sine x because differentiate sine to get the cos. When I want to get cos 3x, what do I have? I have sine 3x. Differentiate the 3x, I get a 3. So I have to divide it by the 3. Okay, then close bracket, and I want to substitute the limit of pi over 3 and also pi over 4. Okay, so of course, all the integration basic one, you need to go and revise it a bit. All right, then now let's substitute in all the value here. Sine pi over 3. Okay, minus 1 over 3. Sine 3x means sine pi. Okay, then minus, now substitute in pi over 4. Sine pi over 4 minus 1 over 3, then sine 3 pi over 4. Okay, so I'm showing you the process of substitution of the limit into the integration term. Then after that, let's figure out the value slowly. Pi over 3 is basically 60 degree, right? So sine 60 degree, you should be having sec 3 over 2. Okay, then minus sine pi, you get a 0. Then next one, sine pi over 4. Sine pi over 4, you should be having sec 2 over 2. Alright, then multiply in, you're having a positive 1 over 3. Sine 3 pi over 4 is in the second quadrant. So for second quadrant, sine value is a positive. So you're still having sec 2 over 2. Alright, so if let's say you don't know how to get all this value, you can always press calculator. And if you are using MS calculator, then no other choice. You have to recall back the triangle, the ratio of the triangle that we learned before. Alright, so when you're having first triangle here that you need to memorize is basically having pi over 6. Then this is 1, 2, sec 3. Then the opposite angle is pi over 3. Alright, then we have another triangle, okay, where it should be pi over 4. So if you're having pi over 4 here, then these two lengths should be the same, which is a 1. Then this hypotenuse is a sec 2. Then this is pi over 4 as well. All right, so this triangle will be very important, especially for those who are using MS calculator, because when you press calculator, right, your calculator might not give you the cert form for MS calculator lah, while using the Casio model. All right, okay, then if you multiply inside, then you should be having 3 over 4 cert 3. All right, then minus 3 over 4 cert 2. Then plus the 3 and 3 can be simplified. You're having 1 over 4 sub 2. Okay, then further simplify it. Okay, so first of all, sub 3, there's no more sub 3 here, right? So you just copy the answer here, 3 over 4 sub 3. Then you treat the sub 2 as apple. So you're having negative 3 over 4 apple plus 1 over 4 apple. So negative 3 over 4 plus 1 over 4, what do you have? You're having negative 2 over 4, which is negative half. So you can make it become negative half. All right, so you can see that basically this is how we keep our answer in the exact form. All right, okay. So basically this is how we solve this question number 3. And again, just some small suggestions here. For recent past year, we can see that there are a lot of integration questions that they will not give you a hint for integrate, the technique of integration. So you yourself have to have the idea, all right, what kind of technique or maybe what is the suitable identity for the trigo for you to use and solve it in the integration part. All right, so I will see that the compound angle formula pair like cos A plus B, cos A minus B, then sin A plus B and sin A minus B are suitable identity to be used when you want to integrate all this. If you're having sin A cos B for the integration, or maybe cos A sin B also can. All right, or when you're having sin A sin B, or cos A cos B. So when the question want you to integrate all these specific type of trigo function, unless they give you other extra hint, okay? If they didn't give you any extra hint, like this question, then by right you should know that, oh, for sin A cos B and cos A sin B, you can use the compound angle formula pair, which is sin A plus minus B. Right? So if let's say you're having sin A sin B and cos A cos B, then generally the compound angle formula you can be used is cos A plus minus B. All right, so this is just a small suggestion or maybe just extra knowledge for you to know about it. Okay, all right, so this is how we solve question number 3. All right, so next one, let's have a look for question number 4. We are given that the coefficient of x power 3 in the expansion of this particular bracket with power 2 over 5 is 1. So find the value of a. So to get the coefficient of x power 3, basically we have to expand this bracket with power by using binomial expansion. All right, so let's start with the binomial expansion first. Okay, so what is the formula for this binomial expansion here? So just a recall again. All right, so if let's say I'm having 1 plus x power n, where the n can be any fraction or negative fraction or positive fraction or negative value, then we can expand it using binomial expansion formula. All right, so the first term is always a 1, the second term is nx, the third term is n minus 1 divided by 2 factorial with x squared. Then the next term is n minus 1. Okay, so I'm having n, then n minus 1, n minus 2 divided by 3 factorial with the x power 3. Of course, we can extend it to more terms. All right, okay, but we are looking for up to x power 3 only, so I just keep it up to x power 3 here. Okay, then just extra information that you need to always remember to apply this formula, right? This formula is provided in the formula booklet, so you can refer to the formula booklet if you want. Then to apply this particular formula, you have to ensure that the first term here must be a 1. So this one must be 1. It cannot be any other value, right? So you have to take note on this. Okay, right, so we are going to apply this formula here. So let's have a look for our question. Okay, I'm having this bracket, so I just write out this bracket first. I'm having 1 minus ax power 2 over 5. Okay, so first term is a 1. My first term already start with 1, right? So I can directly apply this formula. So first term is a 1. Second term is nx. My n in this case is 2 over 5. X in this case is negative ax, the whole term at the back. Right? So nx. Then plus the next term is n minus 1 divided by 2 factorial, then x squared. So negative ax, you square it. So this is x squared. Next one, n minus 1, n minus 2 divided by 3 factorial with the x, which is negative ax in our case here, then power 3. Okay, then of course there are more like x power 4, x power 5 and so on, but I doesn't want to expand it anymore because our focus is up to x power 3 only. Okay, alright, then given that the coefficient of this x power 3 is equals to 1. Alright, so what are we going to do here is we are trying to use the coefficient of x power 3. So what is the coefficient of x power 3? Basically, it is this one, including the negative a with power 3. Okay, alright, so if I rewrite it again, then basically you will know that the coefficient is 2 over 5. 2 over 5 minus 1 is negative 3 over 5. 2 over 5 minus 2 is negative 8 over 5 divided by 3 factorial multiply with negative a power 3. This whole coefficient here should be equals to 1 because it is a coefficient of x power 3, right? So this whole coefficient should be equals to 1. Okay, so simplify the values here. When you try to simplify this value here, simplify it together with negative a power 3, you should be having negative 8 over 125 with a power 3 equals to 1. Okay, it also means that a power 3 is equals to the value of negative 125 over 8. Then to get the value of a, what should we do? We have to take the cube root, right? So the cube root of negative 125 over 8. So what do you get for the value of a? By right, your a should be equals to negative 5 over 2. Right, so this is what we have for part A, the value of the a. Okay, then continue to part number B. Hence, find the coefficient of x power 4 in this particular expansion. All right, so they want to extend it and make it bigger, where you take your first bracket in the first part, multiply it together with 2x plus 1, and they want to get the coefficient of x power 4. Okay, all right. So let's set up the question first for part B. Okay, so for part B, I'm having this bracket 2x plus 1 multiply with 1 minus ax power 2 over 5. Okay, then we want to focus on only the coefficient of x power 4. Alright, so basically, you can expand everything if you want. But for me, because I want to save a little bit of time, alright, so I just want to focus on what I want. When I expand this particular expansion here, if I want to expand this particular expansion, I'm having 1, then plus nx with x power 1. This one is x power 2. This one is x power 3. Like what I told you just now, we are having x power 4, x power 5, and so on. Then when I want to put all the expansion here, and I want to multiply with this particular bracket, right? So that means this particular bracket, 2x, I need to multiply something here with the x power 3. So that when I multiply these two terms together to have something with x power 4. You understand what I said or not? Therefore, when I want to apply the expansion here, right? I don't expand from the beginning anymore. What I do is like, I just try to take whatever the terms that I need. So for this one, I need something with x power 3. So just now they already told us that the x power 3, the coefficient is a 1. The coefficient x power 3 in this expansion is a 1. Therefore, I know that this whole thing here should be 1x power 3. So I put it here, 1x power 3. Okay? Then after that, so I know that 2x multiply with x cubed to get something with x power 4. Because in this question, we are interested for the coefficient x power 4. I need one more extra term here because 1 multiply with something, I can also get x power 4, right? So that means what? That means this particular term in this expansion must be the term of x power 4. So I need to further expand it. So what's the formula for x power 4? So I'm having n minus 1. I directly write out the value. N minus 1 is negative 3 over 5. N minus 2 is negative 8 over 5. N minus 3 is negative 11 over 5. Oh, sorry, 13 over 5. Okay, so I'm having n minus 1, n minus 2, n minus 3 divided by 4 factorial. Then ax power 4. So your a is negative 5 over 2, right? Okay, so negative 5 over 2. So when you put it inside your equation here, negative ax, it means that it becomes positive 5 over 2x. Then you close the bracket. That means I'm having 2x multiplied with something x power 3 to get the x power 4. The first term here, the term of 1 here, multiplied with something x power 4, I'll get x power 4 also. So this is how I group all the x power 4 together. Okay? Then let's continue further. Before expand it, I just try to keep it like this first. Okay, so x power 3, still x power 3 lah. This part looks so complicated, right? Can you just try to press calculator and simplify it first? If you didn't do any careless mistake, this value that you get should be negative 13 over 8 x power 4. Make sure you press calculator and try it out, yeah? Don't simply copy the answer, okay? Alright, then after that, I start the expansion. So 2x multiply with x cubed. I'm having 2x power 4. Okay, then 1 multiply with this one, I also get power 4, right? But I get negative 18 over 8 x power 4. Alright, so I'm having both term x power 4. I can simplify them. So what do I have here is 3 over 8 x power 4. And according to this question, we are looking for the coefficient of x power 4, correct or not? Yeah, so to write out the coefficient x power 4, please write out one more time. Coefficient of x power 4 should be equals to what? Should be equals to positive 3 over 8. Alright, so this is what we have for part B in this question. Okay, then next, we are still having part 3. So for part C, state the set of values of x for which the expansion in 4b is valid. Alright, so when you want to apply any binomial formula, right, binomial expansion formula, especially for this one, there's a restriction basically, and this restriction we call them as the set of value of x. So the general rules to write out this set of value of x basically is like this. You take the modulus of the term at the back, modulus the term at the back, which is the x for this case, smaller than the number in front. So this is a set of value for x so that the expansion is valid. Okay, then according to our expansion here, we are having this one, 1 minus ax power 2 over 5. To write out the valid value for x in this set, again, what I put is I put modulus first of ax. A is negative 5 over 2 so negative become positive, so positive 5 over 2x modulus. Okay, that's smaller than the number in front, smaller than the number in front. Okay, so the 5 over 2 is a number. I just want to take it out. So 2 multiply to the other side become positive 2. Become the numerator 2 divided by the 5. So if you try to expand it, your valid value of x will be, x must be between negative 2 over 5 until positive 2 over 5. Alright, so this is basically how we write out the valid value for x. Okay, yeah, so for part C, we just need to write out the answer where the x is from negative 2 over 5 to positive 2 over 5. Alright, so this is how basically we solve question number 5. Alright, so now we are at question number 5. Given a complex number z, yeah, with this fraction, where lambda is a real constant, find the value of lambda where the argument z is pi over 4. Okay, so when you are having any complex number, right, we actually don't like to keep it in this fraction form. We are going to fraction with the I form at the denominator. So we prefer to rationalize them first. Alright, so to rationalize them, we have to look at the denominator. We are having lambda plus 2i. So to rationalize it, what we need to do, we have to multiply with the conjugate of denominator, which is lambda minus 2i. For both top and bottom part. So we rationalize it first. Okay, so for rationalization, you need to just be more careful. So lambda multiply with lambda, you're having lambda square. Positive 2 lambda I minus 2 lambda I becomes 0. Then you're having negative 4i squared. So negative 4i squared become positive 4. Okay, so I just want to make sure that you understand this one. So negative 2i multiplied with positive 2i. So you're having negative 4i squared. So you should know that I squared is what? I squared is the value of negative 1, right? So negative 1 times negative 4, therefore you're having a positive 4. Okay, so we settle for the denominator part. Then you can see that after you rationalize it, there's no more I at the denominator. Okay, so for numerator, we just expand our bracket on top. So I'm having 3 lambda minus 6i. Then plus lambda square I. Then negative 2 lambda I squared. So negative 2 lambda I squared become positive 2 lambda. Agree? Alright. Then after that, I want to group it real part to the real part, imaginary to imaginary part. So 3 lambda and 2 lambda has no I. Therefore, I can group them together, become 5 lambda over lambda square plus 4. This is the real part. Then plus imaginary part, I'm having this one, negative 6i plus lambda square I. So if I group them together, I'll be having lambda square minus 6 divided by lambda square plus 4 with the I at the back. So this is the imaginary part of the complex number z. Alright, and after we rationalize it, this is basically what we have. We are having real part x plus yi. This is the complex number z. How can I get the value for lambda basically? So after we rationalize it, what are we going to do is like we are going to use this information. Argument z is equals to pi over 4. How can we get the argument of z? So argument of z, basically we are taking b over a or y over x, then tangent inverse. Alright, okay, so to get the argument of z, basically argument of z means tangent inverse b over a. So my b is the y, which is this one. Okay, so b over a, if I put it in the big bracket here, so pi square minus 6 divided by pi square plus 4 divided by the x, so 5 pi over pi square plus 4. This is the argument of z, then equals to pi over 4. Okay, so next, I bring the tangent inverse over and I'm having tangent pi over 4. So tangent pi over 4, I'll be getting a 1. Then for this fraction inside, I try to simplify it. So pi square plus 4, pi square plus 4 can be simplified. Okay, so eventually for this part, you're having pi square minus 6 over 5 pi. Okay, so to solve for this equation, you bring the 5 pi up, then bring it to the left, become negative 5 pi. And you can see that basically you are having a quadratic equation in terms of lambda, right? Okay, sorry, not pi, it's lambda. Okay, so for all the lambda here, you can get the value of lambda by factorizing this equation. I'm having lambda minus 6, because 1 negative 5, right? So minus 6, then lambda plus 1. Okay, then after that, I'm having lambda equals to 6, and also lambda equals to negative 1. Okay, so according to what we have here, if you try to read the question one more time here, they said find the value of lambda. This actually gives us a hint. They are not saying about values, but they are talking about value only. So the value of lambda. How to get the value of lambda? There should be one value for lambda only, but eventually we're having two here, right? So that means one of the value might be a wrong value. Okay, so how can I know that which one is correct and which one is wrong? So let us go back to our information here about this one. There's a hidden message in this part, this information given. When they said the argument of z is pi over 4, that means your complex number z is in is in the first quadrant. Okay, so when your complex number is in the first quadrant, your both x and y in your complex number must be positive. Okay, all right, so now let us substitute negative 1 into my complex number here. All right, so I'm having negative 5 divided by 5. Then this one, 1 square is a 1, minus 6 is negative 5 over 5 also. So eventually you're having your z equals to negative 1 minus I. This is not in the first quadrant, right? Okay, negative 1 minus I, this is not in the first quadrant, because if you try to draw it out, it should be in the third quadrant. Okay, so very obvious, lambda equals to 1 is not the correct answer. Okay, so if you want to make any explanation, you can make it or make a small note for yourself to take note. Alright, so when lambda is equals to negative 1, z become negative 1 and minus I. Okay, where this argument z is not equals to pi over 4. Therefore, we have to ignore it. Alright, so we only accept one correct answer for the lambda, which is lambda equals to 6. Alright, so this is what we have for 5a. Then let's have a look for 5b. When lambda has this value found in 5a, find the exact value, highlight the keyword exact, of modulus z, making your method clear. Alright, so to get the modulus z, of course, you need to get the z value. Alright, so when your lambda is equals to what? 6, right? Substitute lambda equals to 6 in my z, real and also the imaginary part. 6 times 5 is 30. 6 squared is 36, plus 4, you're having 40. Then plus, same thing happened here. 6 squared is 36, minus 6, you're having 30. Divided by, this one you're having 40. Okay, so you can further simplify it, become 3 over 4 plus 3 over 4i. Then how can I get the modulus of the z? So to get the modulus of the z, you're having the square root of x squared plus y squared. X squared plus y squared. Then basically you're having square root of, when you add them together, so you're having 9 over 8. Alright, so simplify it further, you're having 3 over 2 sub 2. If you want to further rationalize it, then you'll be having 3 over 4 sub 2. Okay, so this one basically is quite straightforward because they just want you to find the modulus of z. Alright, so the more critical part is this one. Because after you get the two value for lambda, please make sure you go and double check which is the correct value for lambda only. Alright, so we only accept the lambda equals to 6. Alright, so this is how we solve question number 5. Right, so question number 6, we are given a polynomial denoted by px. So first they are telling us that the x squared plus x plus 1 is a factor of px. So highlight the keyword factor. The word factor here tells us that if we try to divide it by using this x squared plus x plus 1, right, there's no remainder because it is actually the factor of the polynomial. Right. Okay, so now for part A, they want us to find the values of A and B. There are two methods to solve this question, I believe. The first one maybe is a long division, and the second one is by using the comparison. Alright, so for me, I'm not using long division here. I never try, but I don't want to use it because I feel that when I'm having the unknown in the polynomial, my long division might look very complicated. Okay, so what I do is like I'm using the comparison where I try to form the equation. So according to what we learned before, to get the polynomial, right? So basically it is divisor multiply with the quotient and then plus the remainder. And I want to apply this formula in my question here. My polynomial is 2x power 4 plus ax cubed plus 4x squared plus bx, then minus 3. Equals to, the divisor is actually the factor here, like x squared plus x plus 1. Then I need to write out the quotient by myself. So the first term of the quotient is, you are taking the x squared multiply with the first term of the quotient to get the first term of the polynomial. So what should I put here? I should be putting 2x power square, power 2 here, right? So 2x power 2 multiply with x power 2 to get 2x power 4. Alright, then after I write out the first term already, then the next term will be ax. You have to write the power of x 1 degree lower until you get a constant term. Okay, alright. Then ax power 0, then the next term will be power b bx power 0. Okay, then plus remainder. So for this case, we have no remainder because remainder is a 0 here. Because they said it is actually a factor. So when you divide the polynomial by using x squared plus x plus 1, there will be no remainder directly. So it will be a plus 0 here. Okay, so this is basically my equation on the right hand side. Divisor multiply with the quotient or factor multiply with the factor without the remainder, right? Okay, then after that, let us expand our right hand side. I'm having 2x power 4 ax cubed bx squared. 2x cubed ax squared bx. Then 2x squared plus ax plus b. Okay, then what am I going to do now is I group all the power, same power x together. So the first one I'm having 2x power 4 once. So I just copy it. The second one is I'm looking for x power 3. So I'm having ax power 3, 2x power 3. So what I write here is a plus 2x power 3. Then next, I'm looking for x power 2. So b, a, 2. So if I simplify, I'll be having a plus b plus 2 x squared. Then for the a here, I'm having, for the x power 1, I'm having b and also the a. So b and a is what? A plus bx. Then the last term is without the x1, which is only the b. And now after I successfully expand them, I just want to compare left-hand side and also the right-hand side for all the coefficient of the x. Okay, so you compare left and right hand side, yeah? Alright, then what's the first thing that I can compare first? I want to compare the constant term first. Negative 3 is a constant term. On the right hand side, b is a constant term. So very easily, you already get your b equals to negative 3. Okay, alright. Then after that, what else can I compare? So second thing I want to compare is the x squared. A plus b plus 2, I want to compare it with 4. Okay, so a plus b plus 2, I get a 4. So what's the value for the b here? So the value for b is negative 3. So you're having the a equals to 4 minus 2. Negative 3 you bring over become plus 3. So a will be 4 minus 2 is a 2. 2 plus 3 you get a 5. Alright, but for this question, basically they want to find out the small letter a and b, right? Okay, so after you get the a, b, and 2, then next one, you can get the value for small letter a by comparing it with a plus 2. See that? coefficient of x cubed is a small letter a. Coefficient of x cubed is also a plus 2. Alright, so small letter a is actually equals to a plus 2. So what is the value for a? Just now you already get a 5, right? So the small letter a here, you get a 7. You successfully get the small letter a value. Then after that, I want to get the small letter b. So the value of small letter b is bx power 1. I compare it with a plus bx. Alright, so b equals to a plus b, capital letter. So what's the value here? A is a 5, b is negative 3. So the small letter b is basically 2. Right, so this is by using the comparison method to get the value for small letter a and b. So another option that you want to try or you want to use can be the long division if you want. Okay, all right, so let's have a look for next part, part B. Hence, show that x plus 3 is a factor of px. So to show that x plus 3 is a factor, what we can do is that we can use a factor theorem. We try to substitute negative 3 into the polynomial. If the answer is 0, then basically that means our x plus 3 is a factor. All right, so to show this one, we are using the factor theorem here. So what we do is like, we rewrite our px again. So what is my px here? It should be 2x power 4 plus 7x cubed plus 4x squared. Okay, then plus 2x, then minus 3. Okay, then now I want to substitute the value of negative 3 into my polynomial. Okay, then you try to do a little bit of calculation. So I'm having 162 minus 189 plus 36 minus 6 minus 3. So I get a 0. Okay, so once you get a 0, that means basically the x plus 3 is a factor of your px. So factor means that when you divide it, there's no remainder one. All right, so by using the factor theorem, as long as you get p a equals to 0, basically x minus a will be the factor of that polynomial. Okay, so this is how we solve question. All right, so we are now at question number 7. By sketching a suitable pair of graphs, then show this equation has exactly one root in this interval. All right, so we need to draw a pair of graphs, right? So what kind of graph should we sketch? So basically we are sketching these two, yeah? So y equals to ln x. Another one is y equals to cosecant half x. All right, so when you want to sketch these two graphs, okay, so let's show here. Okay, so basically what do we have is ln x from 0 to pi. So from 0 to pi, our ln x graph should look something like this. Okay, so we are having a curve like that going up. Then this one is basically the 1. Okay, because ln 1 is always equals to 0. This is the value of x, this is the y. And we are having ln x here. Okay, then we assume that this point itself is up to pi. Okay, all right. Then when we want to sketch cosecant x over 2, cosecant x over 2 comes from the graph of sine, correct? So because cosecant is one of the sine. Therefore, I start sketching it by using the sine graph first. So my original sine graph is from 0 until pi, where this is actually pi over 2. Okay, this is the sine x graph. When I want to draw 1 over sine x, my graph will become something like this, where the 0 here, okay, at the line of y equals to 0, these two lines here will become the asymptote. So I'm having asymptote at this point and also this point, this line, okay, for the cosecant graph. This is actually the pi, all right, this is a 0. Okay, it will become asymptote here. Then for my maximum point, this is my maximum point, right? It will become a minimum point when I want to draw reciprocal function. So the minimum point will look something like this. Okay, then this value itself, it is still a 1. 1 divided by 1, still a 1. Okay, so since I know that this is a minimum point at pi over 2, and I'm having asymptote here, therefore, when I try to draw my diagram, it should be something like this for cosecant x. Okay, then now we are looking for cosecant x over 2. So for cosecant x over 2, what should we do here is basically we need to multiply. Okay, when you're having x over 2, that means you are having half inside your basic function. Therefore, it is actually a horizontal stretch with a stretch factor of 2, right? This is something that we learned in AS before, so we are trying to just recall back what have we learned before and we apply it here. Okay, so horizontal stretch by having the stretch factor of 2, that means all your x value here, you need to multiply with 2. So pi over 2 multiply with 2, you get a pi. So this one, you get a 2 pi now. All right, then for our question, they only want us to show graph from 0 to pi. So cosecant x over 2 will be 0 to pi, and we are only taking this part of our diagram. All right, so when I draw this part of the diagram, it will be something like this. So this is the value of the 1, and we try to label it as y equals to cosecant x over 2. Then the red color graph will be y equals to ln x. Okay, so after we done drawing the graph, then let us continue and show what they want us to show here. They want us to show that there's only one root in this interval from 0 until pi. So how to show that there's only one root? So one root here basically means that there's only one intersection point between the two graphs. Okay, so this is the root. Okay, the value here for the x is the root. So you can see that we have only one intersection point in the graph, in the range that we draw, right? Therefore, you can just make a simple conclusion where you can state that only one intersection point can be seen. Therefore, there's only one root in the interval given. Alright, so basically this is how we get the graph and then how we show it. Then of course you need to make sure that you did mention that there's only one intersection point. Therefore, there's only one root in this interval. Alright, yeah, so this is what we have for part A. Then let's continue to part B. Okay, so for part B, what we need to do here is they want us to prove that our root lies between 2.6 and 2.9. Okay, so first of all, usually formula, I'm using the sign change method where I try to group the equation on top, everything to one side. Okay, so let's say I'm making fx equals to cosecant half x minus the ln x. So I put it in the function form. Of course, if it's not wrong that you want to make it the other way around, where you move the cosecant half x also can. So you're having ln x minus cosecant half x. Both also correct. It doesn't matter one, right? Okay, then after that, if I'm putting the function in this way, then I want to substitute 2.6 and 2.9 into my function. All right, so I'm having cosecant 2.6 over 2. Then minus ln 2.6. I try to get the value by pressing calculator. All right, then just make sure you press calculator lah. Again, cosecant 1.3 here, right? Basically means 1 over sine 1.3. And when you are pressing the calculator, please make sure that you always remind yourself, all your calculator must be in the unit of radian, yeah, in the radian mode. It cannot be degree because this angle here basically is the radian. All right, so by pressing the calculator, if you didn't do any careless mistake, by right, 3 significant answer for this part should be 0.0823. Then the same thing happened here. I want to substitute 2.9 into my function. Then I'll be having cosecant 2.9 over 2 minus ln x, which is ln 2.9. Then press calculator again. So by right, you should be having negative 0.0574. Okay, so usually for me, right, to verify that the roots lie between these two values given, I will want to make my equation into a function. Then I substitute the value given. Then usually we'll see the sign change can be seen clearly. Yeah, when we see the sign change, basically it means that the roots lies between these two values. All right, so you can see that one value is positive here, another one is the negative here. So there's a sign change. Okay, then if you move the cosecant x to the other way just now, then by right, your sign will be opposite. This one will be negative and this one will be positive. All right. Yeah, then after that, don't forget to make a conclusion because we can see the sign change, right? Sign change can be seen between what? Okay, so between 2.6 and also 2.9. Hence the roots. Hence the root lies between 2.6 and also 2.9. Okay, so this is what we have for part B. Then let's continue to part C. They want us to use this iterative formula to determine the root correct to 3 decimal places. Then give each the result for every iteration to 5 decimal places. Alright, so let us copy out the iteration formula first. I'm having x power n plus 1 equals to exponential cosecant half x, right? So if I write it out in detail, yeah, cosecant means 1 over sine. So I should be having 1 over sine with x over 2. Alright, so this is my iterative formula lah. So the x here is the n, xn. Okay, right. So I'm writing it out in this form so that it's easier for us to press calculator to get the value. Okay, alright. So let me show you the calculator here. Wait. So I think I need to just keep it like this. Okay, so for the calculator part here, I need to key in this formula on the right hand side of the iteration equation. So I'm having exponent means exponential with the power of 1 over sine x over 2. So before you want to press any value, right? Again, just a reminder again, because we are having this as a trigo in the unit of angle, right? So the unit of angle is always the radian mode. It's radian in the unit of radian. So please make sure you put it in the radian mode, right? Then I try to key in the formula E. Then power 1 over cosecant, e power cosecant, which is 1 over sine. So I put it as a fraction. So 1 divided by sine, then x over 2. So x over means divide by 2. Then close bracket. Okay, so this is what I have for the iteration formula on the right hand side. Okay, then after that, I need to change my calculator into radian mode, right? So I press shift mode, then into the radian, which is a 4. Alright, okay, so later I need to key in the value one by one so that I can get my iteration formula, iteration value correctly to get the root eventually. Okay, so usually when we want to carry out the iteration process, right, we need to have an initial value. That means the first value to start with. So what's the first value to start with? Usually I will suggest you to use any value that is near to 2.6 to 2.9 because we know that our root is close to these two numbers. Correct or not? So we try our best to choose any value that's within this range. Right, either 2.6 also can, 2.9 also can. If you want to do the center value also can. All right. Okay, so for my example here, I'm trying to take 2.8. So I let my x1 equals to 2.8. Okay, then how can I get the x2? So to get the x2, basically what I need to do is like I have to put in 2.8 in my equation. So that means I'm having sine 2.8 divided by 2, which is like 1.4 lah. Okay, then cosecant 1.4 to the, for the power of the e. Okay, then in my calculator here, you just press calculate, then press the value that you want to key in. So your value for x should be 2.8. Then you press equal sign. And this is the second value, the x2 that you should get from your calculator. And then according to our question here, they are saying that each iteration to 5 decimal places. So this is my iteration, right? So my iteration should be 2.75872. Okay, so 75872. I'm having 2.75872. Correct to 5 decimal places. After that, we want to go for the next iteration, which is x3. Now I put this value into my iterative formula again. So I just repeat it by using the calculator. So I press calculate again, key in the value of 2.75872. Then press equal sign. So the next iteration I get is this value, 76934. Okay, then let's continue further. For x4, repeat the process one more time. Press calculate, press the value 2.76934, then press equal sign. Then you're having 76648. So 2.76648. Okay, then let's continue further for x5. Okay, go to the calculator one more time, repeat the process, press calculate, then 2.76648. Then press equal sign, 2.76724. 2.767, then 24. Okay, so maybe some of the students will ask, when should we stop this process, right? Okay, according to the question, because of the question is asking for correct root to three decimal places. So that means if you're having a few values for 3 decimal places repeated, then you can stop that. So let's have a look here. For this one, 3 decimal places answer should be 2.759. Okay, then this one is 2.769, not repeated, right? Then this one is 2.766, also not repeated yet. Then this one is 2.767, still haven't repeated yet. So you still need to continue until you get the repeated 3 decimal place answer. Alright, then I go for x6. Then again, I repeat the same process one more time. Calculate. Then 2.76724. Press equal sign. Then I'm having 2.76704. Okay, so 2.76704. Then if I check for the 3 decimal place answer, it will be 2.767. And you can see here that these two values are repeated already, right? You can stop here if you want. But usually for me, I want it to be more secure. Then what I do is I try to repeat a few more times, just to confirm that this is my final answer. So I press calculate again, then key in 2.76704. Then press equal sign. Then I'm having 2.76709. So 2.76709. Okay, then this value again is 2.767. Alright, so it seems like it has been repeated the same value for 3 times, right? Yeah, then you can write this as a final answer if you want. So if you don't want, then you just double confirm one more value, 2.76709. Then press equal sign, and you get 2.76708, which is still 2.767 as the 3 decimal place answer. Okay, so maybe for the last iteration, you don't need to write all. Okay, then I'm confirm that the final root correct to 3 decimal place is 2.767. Alright, so basically this is how we solve this question number 7. Okay, to get the root by using the iteration formula. Alright, so question number 8, the variable x and y satisfy this differential equation given. Okay, then it is given that we are having x equals to 0, y equals to 0. This is the initial value given. Then we are using it to find the constant term later. right? So solve the differential equation to obtain an equation in x and y. All right. Okay, so to solve for differential equation in our syllabus, first of all, we need to separate the variable first. We are having the variable x and also variable y in this differential equation, right? Therefore, we try to separate them clearly, all the x to one side, all the y to the other side. Okay, so according to what we have here, I'm going to shift the y plus 5 to the left. So I shift the y plus 5 to the left. I'm having y divided by y plus 5 here. Then for the dy. For the x and e power 3x and dx, I want to keep the x on the right. Then e power 3x, if I bring it to the other side, become divide. This one, if you bring it to the other side, become divide, right? So 1 divided by e power 3x will become e power negative 3x. Okay, then for the dx here, you try to move it up to the left-hand side, right-hand side, then you're having dx. Okay, then after you successfully separate all the variable clearly to both different sides, so you can see, oh, everything with the y is on the left, everything with the x is on the right, then you can start to put the integration sign. Okay, all right. Then after that, for this particular fraction, y over y plus 5, when I want to differentiate it, when I want to integrate it, this is not the integration fraction that I can integrate directly, but I can slightly modify a little bit so that it becomes pattern that I can integrate. Okay, so I want to have y on top, right? I want to separate this into a proper fraction. So what do I do here is I try to make a plus 5, then minus 5. Plus 5 and minus 5 become 0 basically, and it is still the same like what we have here on top on the previous step, correct or not? So what is the purpose that I want to make it in this way? Later I will show you, in the next step. Okay, so I want to plus 5 and minus 5 in numerator so that I can separate them, become y plus 5 over y plus 5. Okay, then minus, I copy the minus. Then I'm having another one, which is a 5 divided by y plus 5. Okay, then what's the purpose that I do so? Because of y plus 5 over y plus 5, I'll get a 1, which is the number that I can integrate it very easily. Then for the second fraction here, I'll be having 5 over y plus 5, which is having the pattern of 1 over ax plus b. So I can also integrate this one directly. Okay, if we look at the original function here, original fraction here, I can't directly integrate it because it is an improper fraction. That's the first thing. Then after that, also it does not belong to any f prime x over fx pattern. Of course, some students might use substitution. So if you want to use substitution where the u is equals to y plus 5 as the denominator, also can if you want. All right, so that's another option. Okay, so for me, I try to just separate it, become the proper fraction. So I'm having a number which is very easy for me to integrate. Then 5 over y plus 5 is also very easy for me to integrate. Okay, all right, so this is what we have for the left-hand side. Then let's go to the right-hand side. For the right-hand side here, I'm having the x multiplied with e power negative 3x. And it is a multiplication of two functions, right? Very obvious, huh? So it is a multiplication of two functions. So when you want to integrate this kind of integral, you need to choose a correct technique. So the correct technique that we are using here is integration by part. All right, so integration by part. Okay, so when you want to use the integration by part, we are using, because we have to use the formula. The formula is integrate of u dv equals to uv minus v du. Okay, then we need to decide which one is the u and which one is the integration of dv in our question. Then the rules of choosing here is we are using the LIATE rules. LIATE. Some book they might use ILATE, ILATE also can. All right, it doesn't matter. Okay, but basically this is the rules that we are using, where the L means logarithmic function, like log. Inverse, I means inverse trigo. For our example in the syllabus, right, we only have tangent inverse so far. Then the A is algebra, all the polynomials or number. Then T means trigo, all the trigo that we have, sine, cos, tangent, secant, or whatever. Then E means exponential function, E power anything. If let's say your function belongs to the higher group, it will be the U. Your function is at the lower group, then it will be the integration of dv. Okay, then let's have a look for the right hand side. I'm having the x. For this x here, it belongs to algebra A. E is exponential, which is the E. Alright, therefore, if I want to apply integration by part in this right hand side here, my x is at the higher group. E power negative 3x is at the lower group. Therefore, the higher group should be the u, the lower group should be the integration of dv, right? Okay, so I just put it in this way, in purple color. Okay, so I know that my u is equals to x. Integration of dv is equals to the integration of e power negative 3x dx. Because I just take out the x from my integration, so the remaining part will be the integration of dv, the remaining part. All right, so differentiate the u, what do you have? You're having du over dx, which is equals to 1. Okay, so your du is equals to dx. And then for the integration, integrate 1 dv, you're having a v. Integrate e power negative 3x, you're having e power negative 3x. Differentiate the power, you get negative 3, right? So I have to divide it by negative 3. Then this is not the end of the integration yet, therefore I didn't put the plus c at this step yet. Okay, so I will put it at last after I complete everything. Okay, so this is what I have for the integration by part. I want to apply the formula now. uv minus v du on the right hand side. Okay, so on the right hand side, I want to apply uv. uv is what? U is the x. So I just put as x. What is the v? V is this whole thing. So I'm having this, which is e negative 3x over negative 3 minus v du. So integrate, you copy the integration sign. What is your v again? So this is your v. You are having e negative 3x divided by negative 3. Then what's your du? Du is actually the dx. So for the left hand side, right hand side, I'm applying the integration by part, which is this formula. Okay, all right. So for the right hand side here, there are many constant, all the negative sign, everything, right? So I prefer to rewrite it nicer. So I'm having negative 1 over 3x with e power negative 3x. Then for this part, I'm having a positive of 1 over 3. I prefer to take out the constant and I don't like to keep it inside the integral. So I'm having e power negative 3x dx in my integral. Okay, all right. So let's have a look for all our equation here. For now, right, you can integrate this one very easily. This part you can also integrate very easily. So we'll continue with our integration. This term already been integrated, so I just copy it. 1 over 3 is a constant, so I just copy it as a constant. Then, what is this one? How to integrate e power negative 3x? You'll get back e power negative 3x. Differentiate the power, you get negative 3, so you have to divide it by negative 3. Alright, then for the right hand side, because everything has been completed for the integration, so I just put a plus c here. Alright, okay, then let's continue further. We have done with our right hand side, but we haven't done with left hand side yet. Okay, integrate the 1, you'll be getting the y. Okay, so 5 is a constant, I just copy it. Integrate 1 over y plus 5, you'll be having ln, then y plus 5. Divided by what? Divided by the differentiation of y plus 5. Differentiate y, you get a 1, right? So divided by 1. Then the left hand side also, I have completed the integration. So supposed to have another constant term plus a or whatsoever. But I'm trying to move this plus a to the right hand side. So I group everything together, become one complete or a single constant term, which is a c, a big c. Okay, so I didn't write any constant term on the left. Okay, so I'm assuming that I group all the constant term that I have as one general constant. Okay, so I keep my constant term on the right hand side. Okay, then I try to further simplify all my final answer first. So this plus C now is a bit different from just now. So this plus C is basically adding the constant term from the left hand side. Okay, so for me myself, I'm keeping the constant term on the right. Okay, so if you prefer, you can also keep all the constant term at the left hand side also can, no problem at all. All right, just that if let's say eventually when you try to find the value of C, if let's say I put my C here and I get the value of C is a 5 here, then if you put your C over there on the left, then your C later will be an opposite sign, which is a negative 5. As an example, if let's say I'm having a positive 5 here, then when you put the C here, the C will be negative 5. All right, so it doesn't matter which side you put. So this is a lot of students asking the same question. When they are trying to solve the differential equation, right, they always ask, hey, why you put the C on the right hand side? Actually, it doesn't matter. You can put either left or right, but we just keep everything at one side only. Okay, all right. Then let's continue further. Seems like my integration already completed, but this is not my final answer yet, right? Because they have already given us the initial value. When x is equals to 0, y is also equals to 0. So we want to use this particular point or particular initial value to find the value of the c. So let's continue from there. Okay, so given x equals to 0, y is also equals to 0. What will happen to our equation? Y is a 0, right? Okay, so you have a 0, then negative 5 ln 5. X equals to 0, so it becomes 0. Then this one will be negative 1 over 9 e power negative 3x, then plus c. So from here, you can see that your c is 1 over 9 e power negative 3x minus 5 ln 5. Okay. Oh, sorry, I forget to put in the value of the x here, right? So the value of the x here is a 0, so it should be e power 0. So e power 0, you should be getting a 1, sorry. So your c is basically 1 over 9, 1. E power 0 is a 1, so 1 over 9 minus 5 ln 5. This is the correct one. All right, then we read through the question one more time. What are they want? What do they want us to keep our answer? So solve the differential equation to obtain an equation in x and y. So they didn't mention x in terms of y or y in terms of x. Therefore, we just need to rewrite our solution one more time only with the value of the c. So y minus ln minus 5 ln y plus 5 equals to negative 1 over x e power negative 3x e power negative 3x again. Then your c is 1 over 9 minus 5 ln 5. Okay, so of course, if you want, you can further simplify it. But since this question didn't request for anything, so I just keep my answer like this. Okay, then when I'm trying to record this video, the official marking scheme haven't released yet. So I think this is the answer that I can show you. All right, so maybe if let's say during when the marking scheme, okay, the official marking scheme is released, then maybe you can double check and see whether they put the answer in this form or not. Okay, yeah, so this is how we basically solve the question number. All right, so we are now at question number 9. Okay, we are given this integral, then using the substitution of x equals to sec 3 tangent u shows that it can be written as this expression. All right, so the hint is very clear here because they are asking us to use the substitution. All right, so we are having the substitution here. So first, let us start with substitution equation that they give us first. We are having x equals to sec 3 tangent u. All right, so let's differentiate it. I'm having dx over du. Sec 3 is a constant term. I just copy it. Differentiate tangent, you'll be having secant square u. Right, and therefore my dx is actually equals to sec 3 secant square u, then du. Right, so besides the general substitution, you also need to consider the limit. So we are having x equals to 1 and also x equals to 3. So let's change the limit. So when x is equals to 1, what happened to your u? So 1 equals to sub 3 tangent u. Therefore, your u will be tangent inverse of 1 over sub 3. And we'll need to put it in the radian form. So the radian form will be actually a value of 30 degree. 30 degree means pi over 6, yeah? So pi over 6, we have to put it in the radian form. Alright, so same thing happened. We are looking for x equals to 3, the upper limit. So what happened to the value of the u? So 3 equals to sub 3 tangent u, and therefore your u is tangent inverse 3 over sub 3, which is a sub 3 lah. Alright, then by right you should be having 60 degree, which is pi over 3. Okay, so once we successfully change all these details already, then you want to change our integral become what they show us here. Alright, so I will start from the integral provided in the question. We are having x power 3 divided by 3 plus x squared dx. Alright, so what can we do to change everything into u? So I think it's quite obvious and straightforward. Change the limit 1, become pi over u here. Can you see that? So we are having the pi over u, sorry, pi over 6. Then the upper limit 3 will be having the value of pi over 3. Okay, then how about for x power 3? So x power 3, you substitute x by using sub 3 tangent u power 3 divided by, what do we have here? 3 plus x squared. So x squared is sub 3 tangent u squared. Then we are having dx. So how to replace the dx? You can get it from here. We are having sub 3 secant square u du. So sub 3 secant square u du. Alright, so for this particular step, we can see that we have successfully changed everything from x become the u. So that's the purpose of substitution. Okay, then let us simplify further so that we can get a nicer equation like what they want us to show. Alright, so we expand all the bracket here. Okay, so sub 3 tangent u power 3, I will be having 3 sub 3, then tangent cube u. I think you should know, right? We have to put the 3 to the sub 3 power 3, and then also sub 3, and also the power 3 into the tangent u. So you're having 3 sub 3 tangent cube u. Right, then divided by, for the denominator, what do we have here? So for denominator, we are having 3, 1 plus tangent square u. It is because of when I square this particular term, I'm having 3 tangent square, right? So 3 tangent square plus 1. The 3 tangent square plus 3. So I factorize out the 3. Then I left only 1 plus tangent square inside. Okay, then after that, for this particular part here, I just copy it. Okay, so how can we further simplify all this to get a better equation like what they want us to show? Right, so first of all, you can see that the 3 and 3 can be simplified for now. Okay, then what do we have here is we left only sub 3 tangent cube u on top, right? Okay, so I'm having sub 3 tangent cube u on top. And what is the 1 plus tangent square? 1 plus tangent square, basically you can make it become secant square, according to the identity that we have in our syllabus. Alright, so 1 plus tangent square equals to secant square. Then I still have sub 3 at the back, secant square u at the back. And there's one more thing that we can further simplify. Secant square and secant square can be simplified. Multiply the 2 sub 3 together, so you'll be having 3 tangent cube u, which is the expression that they want us to show. Right, so this is basically what we have, how we are changing all the integral in terms of x become everything in terms of u. Right, so this is what we have for part A. Then let's have a look for part B. Hence or otherwise, find the exact value of I. Highlight the keyword exact your final answer must be in the surd form or pi form or ln form. Okay, they have telling you that give your answer in this form, p plus q ln r, where p, q, and r are rational. Okay, right. So how are we going to carry out this integration? Most of the time, basically, every time when they ask us to prove something to something, right? What am I going to do is like, for integration, I will directly use the result that they are giving us in the previous part. Okay, so for this integration for I will directly start from this result, from first part of part A. Okay, but of course, we need to think further lah. How can we rephrase our equation or expression so that we can get the integration correctly? Okay, so I'm having 3 tangent cube u. Okay, so we never learned how to integrate tangent cube before. And usually for anything that involve the tangent with power 3 or whatsoever, we always try to rephrase it. All right, of course, this one needs some experience. So you need to rephrase your expression so that it has something related to the differentiation of it. So as an example, I know that if I differentiate tangent, I will be having secant square, right? So I'm trying to think, is there any way so that I can include the secant square in my integration or not? So that's one direction. All right. And of course, for all the details, right, you need experience to get the idea. All right. So you try, if you try more questions, then it will be better for you to have the idea how to solve it. Okay. Right. So first of all, because I want to include something related to secant square in my integration, so what I'm going to do here is I try to separate the tangent cube, become tangent x, tangent u, then multiply with tangent square. Why do I need to separate it become tangent u and also tangent square? It is because of I want to use the result of tangent square u, which is equals to secant square u minus 1. Okay, so that's the purpose. I want to include the secant square in my integration. All right, then again, if let's say you memorize the identity, right? I'm using this one. Use the identity 1 plus tangent square equals to secant square. Okay, therefore, tangent square can be written as secant square minus 1. All right, so how I know that I need to use this? Like what I said just now, for integration, right, I always try to think about, can I rephrase my equation into something related to the differentiation of one of the function? So like I differentiate tangent, I'll get something with secant square. So that's my purpose. I try to rephrase tangent become the secant square. Okay, all right. Then after that, let us proceed further. 3 is a constant, therefore I prefer to take it out. Then I try to multiply the tangent u into the secant square. And also this one. Excuse me. Okay, so let's have a look further. What kind of pattern do I have here? Okay, so basically I'm having tangent u multiplied with secant u, then minus tangent u du. All right, and for this tangent u du, tangent u du, I might want to rephrase it further because tangent can be written as sine over cos. So I can write it become sine u over cos u. Okay, and why do I need to rephrase the tangent become sine over cos? Again, it is because of, I know that sine and cos is the differentiation function of each other. So that means if I have a look for this one, I make it as function fx, then this one will be f prime x. Okay, when I want to integrate f prime x over fx, we did learn the formula before, right? So what is the formula that we have before? So if you want to integrate anything with f prime x over fx, for this particular pattern, you'll be having ln fx, then plus c. Okay, so for this particular second term here, we are going to apply the integration later for this one. Okay, but before that, I need to make a small adjustment also, because I realized that when I'm having cos u is my fx, differentiate cos u should have negative sine u, right? I want to have the negative at the sine part. Therefore, this one I put it as a plus. Okay, so I'm having the negative sine u over cos u for this particular phrase here. Okay, all right, so I'm done for this part. This one I know that later I can integrate directly. Then how about for this particular term? Okay, so for this particular term, I use it in purple color here. I know that if let's say my tangent u is fx, then differentiate tangent, you'll be having secant square, right? So the secant square is my f prime x. All right, then when I'm having anything with f prime x and also the fx pattern, how can we integrate this particular form? So to integrate this particular form, basically it's like this. Okay, so when we want to integrate fx with any power and also the multiply with f prime x, then basically you only integrate the function fx power n. So if you integrate the function fx power n, you'll be having fx power n plus 1 divided by the new power n plus 1, then plus c. Okay, so for recent years, the integration technique become more and more complicated, and you need to aware, all right? There are some basic patterns that involve f prime x, and fx pattern one. Then this is the way that you integrate them. All right, so I assume that I'm having fx power n multiply with f prime x. Therefore, when I want to apply the integration, I will ignore the f prime x and I only integrate the fx power n. Okay, so power plus 1 become n plus 1, then divided by the new power n plus 1. Alright, so for this part also I have settled it. Alright, I know that my tangent u is fx power 1. The n is power 1 here. So later when I want to integrate, it will become power 2. Okay, so after I'm done with all the details here, okay, so let's continue to the next step and we start the integration. So what's the integration that I have here? Okay, integrate tangent. Right, so integrate tangent u multiply with secant square u, like what I told you just now. I want to integrate the function fx with power n. I'm having fx power 1 in this case. Therefore, if I integrate, I will be having tangent power 1 become power 1 plus 1. So power is a 1, plus 1 become a 2, right? So I'll be having tangent square u divided by the new power, which is a 2. Okay, then I'm having pi over 3 and also pi over 6. Okay, so plus, you copy a plus. 3 is a constant, so please include the constant in the second integration here. Now I'm having f prime x over fx pattern because differentiate cos x, I'll be having negative sine x. Or I should say negative, differentiate cos u, I'll be having negative cos u. Okay, so integrate this one, I'll be having ln. Then fx, my fx in this case is cos u. Okay, then of course we need to put in the limit of pi over 3 and also pi over 6. Alright, so let's continue further. After the integration, we need to substitute in all the value. Alright, so substitute in the limit, substitute in pi over 3 into my tangent square. So I'm having tangent square pi over 3 minus tangent square pi over 6, sorry. Okay, then plus 3 ln cos pi over 3 minus ln cos pi over 6. Alright, then we slowly put in all the possible values that we have here. What is the value of tangent pi over 3? So tangent 60 degree, you'll be getting sec 3. So you are having sec 3 square. Then minus, okay, tangent square pi over 6, tangent 30 degree. Tangent 30 degree will give you a value of 1 over sec 3. So we'll be having 1 over sec 3 square. Okay, then plus 3. What's the value of ln cos pi over 3? So ln cos pi over 3, cos pi over 3 is cos 60 degree, which is half. Cos 60 degree is a half, right? Then minus ln cos 30 degree will give you sec 3 over 2. Okay, so just in case for those who are not using who are still using MS calculator but not using ES or EX plus other version of calculator, to get all this rational, the exact value for the triangle, you basically need to memorize the triangle here. There are two basic triangles that you need to know, right? Okay, so the first one is, let's say you're having pi over, but for our example here, everything that we have is pi over 3 and pi over 6. I assume that this is pi over 3, which is 60 degree, and this is pi over 6, which is 30 degree. So sine 30 is half, therefore I'm having 1 over 2. Then this one should be a surd 3. So all this surd value actually taking from this triangle. Alright, so in case you are not using the ES calculator, you are still using MS calculator, I believe that MS calculator will give you all the decimal number. Alright, it won't show you the how to say, the exact value lah. Alright, so you might need to use this triangle to help you a bit lah. Okay, so after I get all the values here, then I try to simplify them. Okay, so surd 3 squared is a 3 lor. Then 1 over surd 3 squared is 1 over 3. Alright, so when I'm having ln half minus ln surd 3 over 2, what do I have here? I'm going to use the result where I'm having ln A minus ln B, I'll get ln A over B. Okay, so if I want to write out the details here, then we are using the step or the property of the ln, which is the ln A minus ln B equals to ln A over B. Okay, then we are one step closer to our final answer. Okay, so 3 minus 1 over 3. What do you get? You'll be getting 8 over 3. Therefore, I'm having 3 over 2 multiplied with 8 over 3. Okay, then for this part, ln half divided by surd 3 over 2. What do we have here? We will be having ln 1 over surd 3 if you simplify it. Okay, then after that, is this a final answer that we should have? Okay, so let's simplify this answer. 3 over 3 is a 1, then 8 over 2 is a 4, right? I'm having 4, then plus 3, then ln 1 over surd 3. Okay, so maybe we actually don't know, right? Is this our final answer or is this correct final answer that we want to have? So let's have a look for the question again. They did mention, right? So give your answer in the form of P plus Q ln R, where P, Q, R are rational. In short, if you have a look like this, basically this can be your answer already because your P, Q, R is actually is rational. 4 is 4 over 1. 3 is 3 over 1. Okay, then 1 over surd 3 is a rational function. Alright, so for me personally, my own habit, right? I don't like to have any surd 4 at the denominator. So for me personally, I prefer to further simplify it. Okay, so I'm having ln 1 over surd 3. I can write become ln 1 minus ln 3 power half, surd 3 ma. Okay, then after that, if I further simplify it, ln 1 is a 0. So I'm having 0 minus half ln 3. Then if I further simplify, I'll be having 4 minus 3 over 2 ln 3. Okay, then this is my final answer lah. I prefer to have my final answer without any surd form in ln. Okay, so this is my final answer. But of course, according to the question, right, you can stop your answer here because from here you can observe already where we are having P plus Q ln R. All the three numbers here are already the rational number. Okay, so my one is also the same. 4 is 4 over 1, which is a rational number. Q is negative 3 over 2, which is also a rational number. Then 3 is 3 over 1, which is also a rational number. Okay? Can Alright, so this is basically how we solve question 9 part B. Right? In my opinion, this is not an easy question because you need to have the idea where how you integrate this pattern f prime x power n, fx power n multiplied with f prime x. Okay, so this is a special a small technique that you need to know before you apply the integration. Okay, so this is the answer for question number 9. Alright, so we are now at question number 10. We are given the differential equation, or not differential equation, there's an equation y squared equals to this one, where k is a constant. They want us to show that dy dx equals to 2y over x squared minus 4. Alright, so when we are having our dy dx in terms of both x and y, right, very likely we are using the implicit differentiation in the differentiation process. Okay, right. So first of all, let's have a look for implicit differentiation. we just differentiate all the y and x, just like how we learned it before. Okay, so how we differentiate y squared? So differentiate y squared, you'll be having 2y. Then after that, you have to put the dy dx at the back. After you differentiate the y with respect to x, so dy dx, okay, equals to, now you are having this one, this is a fraction, right? So I'm using the quotient rule. So do you still remember what is the quotient rule? So when you are having y equals to u over v, so what is the quotient rule here to get the dy dx? So y prime equals to, you have to square the denominator, okay, then copy the bottom, differentiate the top, minus, copy the top, differentiate the bottom. Okay, so this is what we are going to use now. And then if, in case if you can't remember this formula, it is actually provided in the formula booklet. All right, so let's start with this one. K is a constant, right? So I just assume that it is a K. Okay, so now I start the differentiation now for the quotient. Square the bottom, so square x plus 2. Copy the bottom, differentiate the top. So I copy x plus 2, then differentiate the top. Differentiate x minus 2, you get a 1. Then minus, now you copy the top, differentiate the bottom. So copy the top, which is x minus 2, differentiate the bottom. Differentiate x plus 2, what do you have? You are having the 1. Then close bracket. So you ended the part for differentiation by using the quotient rule. Okay, but of course, we need to further simplify all your terms to get what you see here. Okay, so let's continue for the next step. We need to simplify it very slowly. Okay, so how can I simplify all this? So I try to simplify the numerator on top first. I'm having negative x plus 2. Then divided by x plus 2 squared. Okay, so compared with the answer that we have, what can we see here? They want us to have 2y over x squared minus 4. Okay, but we don't see anything related to our answer now. Okay, so what should we do is like, we try to simplify further and see. What can we do? Okay, so if I simplify what I have here, x minus x becomes 0. So 2 plus 2 becomes 4, right? So by right, I will be having 4k divided by x plus 2 squared. Okay, all right. Then what can we do? Yeah, seems like it's very different from what we have and what we have now, and also what they want us to prove. Okay, so for our answer, we are having dy over dx only on the left, right? Okay, so maybe what I do is like I try to move my 2y to the left hand side. If I move my 2y to the left hand side, then what do I have here is I will be having 4k divided by 2y multiply with x plus 2 squared. Okay, is there any problem so far? Right, then now let us try and have a look again. Okay, for my current answer here, this is what I have lah. And then for my final for the final answer, they want us to show in part in the question, this is what they have. If I try to compare these two, right, the biggest difference that I can see here is there's no k in this part in the final answer, but I still have the k with me. Okay, so what I plan to do is like I try to get rid of the k. How can I get rid of the k? Therefore, I want to start from the original equation that I have here, and I try to substitute in. Okay, so I put it here, yeah. All right, so originally I'm having this one, y squared equals to k x minus 2 divided by x plus 2. If I only keep the k on one side, then move all the other thing to the other side, I'll be having y squared multiply with x plus 2 divided by x minus 2. So to get rid of the k in my final answer, maybe it's good for me to substitute k equals to this one into my current step. Okay, so I will substitute it now. Okay, so maybe the 4 and 2, I try to simplify first. Then this one I'm having a 2 lah. Okay, so I'm having 2y. Then x plus 2 square. Multiply with the k. So for the k, I want to substitute with this expression now. I'm having y square, x plus 2 divided by x minus 2. Okay, so let's see how can we simplify further. Y square and the y can be simplified. X plus 2 and this one can be simplified. And I left only 2y on top as the numerator divided by x plus 2 multiplied with x minus 2. And we know that x plus 2 multiplied with x minus 2, you'll be having x squared minus 4. Let's check and see whether is it the answer that they want us to show. I think yes, right? Yeah. So this is how we get the dy dx equals to this particular expression here. Alright, so let's continue further for part number B. Okay, now they said k is equals to 5. Find the angle between the tangent to the curve when x equals to 3. So they are having two important values now. They tell you that x is equals to 5 and also x is equals to 3. Okay, then find the angle between the tangent. Give your answer in this form. A tangent inverse b over c, where a and b and c are all integers. Okay, so first of all, let us have a look. How are we going to find out the angle between the tangents to the curve? Alright, so to find out the angle between the tangents, basically it is like this. To find the angle between two straight lines. Alright, okay, so to find the angle between two straight lines, we are using this basically. We are using the angle between two straight lines is theta equals to tangent inverse gradient of line number 1 minus gradient of line number 2 divided by 1 plus m1, m2. Okay, so we need actually the gradient of line 1 and line 2 first, alright? Okay, so before you can find the gradient of line 1 and line 2, you need to know what's the gradient of the curve. Let's say we are having what's the gradient of tangent. So you also know that gradient of tangent means the dy dx. Therefore, the m1 and all the m2 here, right, are the gradient of the curve, which is actually the dy dx. Okay, so we need to find out the dy dx for both lines first. After that, only you can apply this formula to get the answer. So that's how we found the angle between the two tangents or two straight lines. Alright, then let us start. Given that k is equals to 5 and also x is equals to 3. Okay, so first of all, let us figure out the value of y first. So I'm having y squared equals to k is a 5, then 3 minus 2, x minus 2, right? Then divided by 3 plus 2, which is x plus 2. Okay, so simplify it, you'll be having y squared equals to 1, and your y can be equals to plus minus 1. Okay, therefore, I know that there are two coordinates. Give me, we want to find the equation of tangent, gradient of tangent at two particular coordinates of two particular points, which is x equals to 3, y equals to 1, and also x equals to 3, y equals to negative 1. Okay, then let's continue further at the point of 3, 1. I want to know the dy dx. What's the value of dy dx? You have successfully found the dy dx just now, right? In part A, which is 2y over x squared minus 4. So 2 multiplied with 1, you get a 2. X squared minus 4 give you the value of 3 squared minus 4. And you are getting the first gradient, which is 2 over 5. And of course, we need the gradient for another line at the point of 3 and also negative 1. What's the dy dx or the gradient or tangent that you have for this case? Then again, it is 2y. So 2y means you're having negative 2 divided by 3 squared minus 4. Okay, so for this particular answer, you'll be having negative 2 over 5. Alright, so we successfully get the dy dx for two separate points here for each of the tangent line. Okay, then we are going to apply this particular formula now. Okay, right, so let's have a look here. Can I just write it by the side so that you can see and refer to the formula that I write here? Okay, so I know that my tangent, my theta is equals to what? Tangent inverse m1 minus m2. So how can I get m1 minus m2? So for me personally, I always make it as a habit. I will take the bigger or positive value in front minus the negative value at the back. So m1 minus m2. So that means in this case, I'm treating this as a m1. Then I treat this as m2. Okay, I try to avoid the negative inside the tangent inverse so that it is easier for us to simplify it. Okay, right, so I'm having m1 minus m2 divided by m plus m1 m2. 1 plus m1 m2. Okay, simplify the number on top. You'll be having 4 over 5. Simplify the number at the bottom. You'll be having 21 over 25. Okay, then press calculator. By right, your answer should be tangent inverse 20 over 21 for your data. Okay, so this is how we get the angle between two tangents or angle between two straight lines. Alright, then let's double check and see does this fulfill the final answer that we want. So they are saying that we are having A tangent inverse B over C, where A, B, and C are integer. So compared with our answer here, our A is basically the 1. We are having 1. Tangent inverse B over C. B is 20, C will be 21, which fulfill the pattern of the question that they want. Right, so this is how we answer question number 10. Okay, so question number 11, we are having the point A and B with the position vector as such, relative to the origin O. So show that the perpendicular distance from A to the line through O and B is 1 over 3 third 65. Okay, so how can we solve this question? We are having the line through O and B. Okay, so we're having a line through O and B. Then I want to get the perpendicular distance from A to the line OB. That means I'm having A here. Then this purple color line will be the line that we want to find, the distance, the length that you want to find. Okay, so this is the D or the perpendicular distance from A to the line of OB. Okay, alright, so how can we find out the perpendicular distance? So first of all, I need to have the vector equation of line OB. Vector equation of line OB. Okay, so how can we write out? The general formula is R equals to A plus TP, where A is the passing point, P is the direction of the line. If I put it into the vector form, passing point A can be 0, 0, 0, can be the B, the coordinate, the position vector of the B. So if you want to put the position of the vector of B, it will be 4, 2, 4. Okay, but for me, I want to choose an easier one. So if I want to choose the easier line, then I will choose the passing point at 0, 0, 0. So this is a passing point, which is origin. What is the direction of the line? So for direction of the line, it will be either OB or BO, up to you. Okay, so I'm using the direction of OB, from O go to the B. That's the direction of the line. So OB is having the position vector of 4, 2, 4. Okay, so this is basically the vector equation of the line OB. Okay, alright. Then let's say there's a point here, which is the foot of perpendicular from A to the line OB. I label it as F. Okay, alright. So because this foot of perpendicular lies on this line OB, therefore the vector equation of OF will be equals to the vector equation. The position vector of 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 F will be equals to the vector equation of the line, which is 40, 2t, and also 4t. Alright, okay, then now, how can we continue and figure out the perpendicular distance? Okay, so let's continue further, yeah? I know that AF is the length that we want to find, right? From A to the F, the length of the line AF is the length that we want to find. Therefore, I try to figure out the vector AF first, so that I can find the magnitude of the AF later. How can I find the AF? It is AO plus OF. Or some of the students, they write as OF minus OA, also cannot, alright? But for me, I'm using the plus one usually. So I'm having AO plus OF, okay? Alright, so what is the vector AO? AO is negative of OA. So negative 2, positive 1. Okay, so I'm having negative 2, positive 1, plus OF. So what's the OF here? OF is this. Okay, so you're having 40, 2t, and also 40. Alright, so if you add them together, what do we have here? We're having negative 2 plus 40, negative 2 plus 2t, then 1 plus 40. This is a vector equation. This is the equation of AF, the vector of AF. Okay, then after that, let's continue further. I know that this vector AF is perpendicular to the vector OB. Therefore, vector AF perpendicular to vector OB, what am I going to do now is, I'm trying to use the result. AF dot OB is equals to 0 because they are perpendicular to each other. Agree? So I'm having negative 4 plus 4t, negative 2 plus 2t, then 1 plus 4t. Dot product with the vector OB. It is 4, 2, and also 4. And we let it equals to 0. Okay, so dot product, you multiply x component with x component, y component with y, z component with z, right? Okay, this is what you should know. Okay, then you multiply 4 with negative 2 plus 40, plus 2, multiply with negative 2 plus 2t, then 4 again, multiply with 1 plus 40. You let it equals to 0. Okay, alright, so maybe for me, I want you to simplify this particular equation. By right, after you simplify it very carefully, you should be having the value of 18s equals to 8, and therefore your value of s is equals to 4 over 9. Okay? Oh, sorry, that's not the s. I'm having the t here. Okay, so t. Okay, so when you successfully get a value t equals to 4 over 9, right? That means I can find out the vector AF. Substitute 4 over 9 into your AF. Okay, so you're having negative 2 plus 4 multiply with 4 over 9. Then negative 2 plus 2 multiply with 4 over 9. And also 1 plus 4, 4 over 9. Okay, then simplify your vector AF. By right, you shouldn't get a very nice number lah. What you get is like this, negative 10 over 9. Then negative 14 over 9. And also 17 over 9. Okay, so by right, you should be having this. Okay, then the perpendicular distance is the d, right? Which is also the magnitude of vector AF. Since we already successfully get the vector AF, so we can find the magnitude of the vector AF, which is the perpendicular distance or the shortest distance. So do you still remember how to find the magnitude of a vector? You're having x squared plus y squared plus z squared square root. Okay, then after that you try to simplify it. By right, you should be having square root of 65. Then you the denominator is square root of 9, right? So square root of 9 can simplify, become a 3 lah. So you're having 1 over 3, then surd 65. Alright, so this is how we prove that the perpendicular distance is surd 65 over 3. Alright, okay, so we've done part A, then let's continue to part B. Now, they say that the point C has position vector of this. Then, given that OC perpendicular to AB, angle AOC is equals to angle COB. Find the values of P and also the Q. Alright, so how can we settle this question number 11, part B? Okay, so we need to solve equation now so that we can get the P and Q lah. So how to solve the equation? We need to use the information provided here first. Okay, so they say OC perpendicular to AB. Alright, okay, so let us start. Part B, OC perpendicular to AB. So first of all, I want to get the vector AB first. So AB means AO plus OB. AO is -2, and also the 1. Then plus OB. So OB is what? 4, 2, and 4. Okay, then for vector AB, I'm getting 2, 0, 5. Right, because of the information OC perpendicular to AB, therefore I know that OC dot product with AB, what do you get? If they are perpendicular to each other, you are having a 0, right? Equals to 0. What's the vector equation for, what is the position vector for OC? It is 3P and Q. What's the vector AB? It is 2, 0, 5. You let it equals to 0. So from here, if I try to simplify, 6 plus 5Q equals to 0. So you can get the value of Q very easily, which is -6 over 5. Okay, then how can you get the value for P? You might need some other information to get the value of the P lah, because here, if you have P multiplied with 0, you always get nothing with the P. Alright, so you successfully found the Q already. Then now let's continue to find the P. We have to use some other information to continue again. Alright, so the other information is this one. Angle AOC is equals to angle COB. Alright, okay, so angle AOC. How can I find out the angle AOC? Right, so to find out any angle between two vectors, right? Okay, as an example, yeah. If let's say I'm having A, B, and also C. Then to find out the answer for theta, the angle theta, if we want to use the vector form, both vector that we are using must be going out from the same point. So that means I need to have AB and AC. And the general formula will be AB dot AC is equals to modulus AB modulus AC then cos theta. It must be the vector that we are using here must be going out from the point A if you want to find the theta at the point A. Okay, so same thing happened here. Now they are saying that angle AOC equals to angle COB. Okay, so for angle AOC, let's imagine I'm having AOC. Therefore, the angle or the vector they are using to form the equation is OA and OC. Alright, so first of all, we are having OA dot OC equals to modulus OA modulus OC then cos theta. The theta here means the angle of AOC lah. Okay, alright, so I erase this particular diagram, yeah. Alright, so what is the AOC? What is the OA? Vector OA is 2, 2, 1. Oh, sorry, 2, 2, -1, right? Wait, so I'm having 2, 2, and -1. Dot product with OC. So what is the OC here? 3PQ. Q, I successfully found the value just now, -6 over 5. equals to the square root of OA, 2 square plus 2 square plus 1 square. Then the modulus of OC is 3 square plus P square plus negative 6 over 5 square. Okay, then cos theta. Okay, then I try to simplify all the term. For the dot product, I have to multiply x coordinate with x, then y component with y, z component with the z. 3 times 2 is a 6. 2 times p is 2p. Then when you multiply 1 and negative 1 and negative 6 over 5, it will be positive 6 over 5. Then we are having square root 9. Then square root. Simplify the number inside, you'll be having 261 over 25. Then plus p square. Then cos theta. Okay, all right. Then I'm having a 3 here, right? Square root 9 is a 3. So square root 9 is a 3. Maybe I bring it over. I'll be having 6 times 5 is 30. 30 plus 6 is 36, right? So I will be having 1 over 3, which is the square root of 9. I bring it over, become 1 over 3. The number here, I add them together. I'll be having 36 over 5 plus 2p. That equals to square root of 261 over 25 plus p square cos theta. And I treat this as first equation. Okay, because I can't find out the answer yet because I actually don't know the value of theta as well, right? Okay, then now I want to form second equation. So to form the second equation, I'm finding out this one. Angle COB. How to find the angle COB? So again, let's say I'm having this angle, and it is basically COB. To form the vector equation, right? The vector formula to find out the theta, let's say this is still theta. So we are using OC and OB. And my general formula will be OC dot product with OB equals to the modulus of OC, modulus of OB, then cos theta. Okay, all right. So maybe for me, I just put OB and OC, easier. I put the OC at the back. Okay, so OB dot product with OC, modulus OB, modulus OC, then cos theta. Actually, from here, I don't know whether you're aware or not, because OC modulus cos theta and OC modulus cos theta, they are the same. So if you are fast just now, right, you can basically move the OA to the other side, this OB to the other side, and then you equate the equation, will do. Right, but never mind, I already find out all the value here, right? So I slowly figure out everything in detail. Okay, so continue. What is the vector OB? Vector OB is 2, 4, 2, 4. Okay, so what is the vector OC? OC is 3p, Q. Q is negative 6 over 5 also. Modulus of OB will be giving me the value of 4 square plus 2 square plus 4 square. OC is actually the same like what we have here. So I just directly write out 261 over 25 plus p square cos theta. Okay, so 4 times 3 is 12 plus 2p minus 24 over 5. Okay, modulus of OB will give you a value of 6. Okay, then square root of this one. Okay, then after that, I want to bring the 6 over. When I want to bring the 6 over and I simplify them, I'll be having 1 over 6, then 36 over 5 plus 2p. And I will make this as second equation. Alright, so I just want you to have a look, yeah? The right-hand side of both equations are the same. This one and this one are the same. So I try to compare and equate 1 equals to 2. What do I have here? So I take the left-hand side of the 1. equals to the left-hand side of the 2. Okay, then after that, I want to simplify from here. Okay, so how to simplify from here? You multiply the 3 over, right? Oh, sorry, I multiply the 6 over here, so I'm having 2. 2 times 36 over 5, I will have 72 over 5 plus 4p. That equals to 36 over 5 plus 2p. Okay, then further simplify all this, you'll be having 2p equals to negative 36 over 5. And hence the p that you get is negative 18 over 5. Right, so to find out the p, the process is a little bit much longer. It's quite long, all right. Okay, so for q, you can get it very easily from the first information. Then to get the p, you might need to form the two equations for the angle first. Then after that, only you compare that and solve. The answer basically will be negative 18 over 5. Right, so this is basically the end of this question and also the end of this paper. Thank you very much for watching the video.